So I'm just getting ready to record a little more. I already have 8 viewers? What the hell? I guess because I was just on earlier. Welcome everybody. Thank you for coming back. So, I think the plan will be, first I want to take this resistor off. That resistor. It's supposed to be a 50 megahertz clock. We were getting like 16.6 megahertz out of it. I have a 1 mega ohm resistor. I don't have a surface mount one, but I might just try soldering this in, or I might just play around with it to see what it looks like with it off. I can show what it looks like with that resistor on before we get started. I'll start warming up my iron. So we've got power to the board. Power on. And what is my clock signal? I should be seeing it on that pin. So there we go. Oops. Just a little higher. All right, there. 16.67 megahertz. It's supposed to be a 50 megahertz crystal. So let's try removing that resistor. Power off. A little bit of flux. Just see if we can take some of that solder off. There we go. Clean that pad up a bit. What did we get with it off? No oscillations, unsurprisingly. See if I can just hold it on there and get it running. There we go. 50 megahertz. That's what we want to see. Now I was doing this earlier with a different, like piggybacking on the existing resistor, and it was, I don't think that's gonna work. Even though the resistance would have been less than 15K, it was working, which is kind of weird. But rather than play around with things, because I know that like most of these circuits use a 1 meg ohm, I will just try and put this one in. Rather than like futzing with it a bunch. Oh, I guess I'm not. I have the camera repositioned. Oh, still powering the board. There we go. Power's off. That should fit. I'll just straighten this pin a little more here. Maybe a little closer than I would want. There we go. That should be all right. We will cut off the leads. I'll give myself a bit of extra. Now that could be a little further apart. Try this. my iron keeps hitting these yellow pins, the JTAG connector, and then I don't touch the pad, and I'm like, why am I not touching the pad? I'm pressing downward. I'm moving my arms downward. There we go. Power on. Are we actually going? No, we're still going at 16.67. So I guess it was just like changing changing it after power on is what's causing this. What if I have other resistors I could throw in there, but if it's powered on, oh, ha! That was, there we go. And then I short it. I have the limit set low, but the inrush is fairly high on this board. So I just have to like bump it a couple times to get past the inrush. Probably not great, but it's also not good giving it like 3 volts, but you know. Let's try a different resistor in there, just temporarily, but I want to power cycle it because the last time, if I put the resistor on while it's powered, then it starts working. Probably if I short the pins, it would start working. Or if I even... Well, what if we did less? Let's see here. I have another 1 meg ohm, so where's my wire? I could try putting a 1 meg ohm in parallel with this one, and assuming that isn't, see, I'm powering again. Let's turn that off. If I looks like it's shorted. Okay. There we go. Now power on with two 1 megohms in parallel. So this should be 500K. And I am not probing it. There's too many things in here. Okay, it's going at what we would expect. Oh, I'm holding on to it. That's a thing. That is a factor. I mean, ideally I would have another alligator clip lead, but you know. So it's power cycle and can we get on the clock pin there? God damn it. I'll stick my probe in there. It's 2 megahertz because this is actually the CPU clock, which is divided by 8. So 16 divided by 8 is 2. 50 divided by 8 is okay, my brain just went completely blank. It's been a long day. So it'd be 6.25. So if we have this working and it's at 50 megahertz, we should see like 6.25 megahertz here. And we're seeing 2 right now. So that's still not doing what we want. But what if I try something a lot smaller? Well, if we try 10K, then the sum will be less than 10K. The series resistance would be less than 10K. Even just putting that on there is not... See, I keep fucking doing that. Shooting up that resistor after I just put it on. Well, this is disappointing. Okay, there's a 1K. 8.75 megahertz. That's not right either. I thought that would be a quick fix, but I guess not. Might as well take this off. Might as well turn the power off. Do I have a short or something? No short. Whew. Yeah, just a lot of inrush. So what I was doing was there's the clock. doing fine without. Twice as fast as what it should be. And there it is, perfect. This is a 1K resistor. But I am also holding it, which I'm always suspect of. Oh. The music is done. Let me just get some more music playing here. All right. Camera with a view of the scope. Suppose I can move this a little. Well, then it blocks the power supply. Okay, maybe not. Put that there. All right, so that resistor. Let me see if I can hold this 1K up against that without touching the thermocouple while getting a good connection of both pins and powering the board on like that. And we get 625. And as soon as we lift off, oh, well, we restart fine. When it's off, it definitely goes back to 16 megahertz, which is the 2 megahertz when we see it. And then with it on, it goes straight back to 65. So I think 1K is our magic. I mean, it's maybe a little surprising why the smaller resistor is doing it rather than the bigger resistor. I would have expected it to need something like bigger, but I guess it could even actually be like a capacitance issue, because we do, if I take this out, power the board off. There you go. I do have a bit of a gap there with the crystal, and it is a 50 megahertz crystal, which is higher speed. With like an 8 megahertz crystal or a 16 megahertz crystal, it probably wouldn't be a big deal, but it's possible that that could be causing our issue. So let's try putting a 1K in there and see if that fixes everything. And if so, we can move on to the next thing. Oh, I have those right here because I was actually going to use these for the LEDs that I'm going to put on next if this works. Alright, let's get one of these puppies out. Iron is still on. Don't need the jumper. Need my tweezers, they're my tweezers. What way is what way? That looks like it is. That way. That looks like it is. With the numbers upwards, it's a minor thing given how effing small these things are, but I like to put them all in like the same direction so that you can read it properly. Without having to flip it around or like flip it around in your mind. That is too much. There we go, 6.25. All right, so that is our fix. I'm just gonna make a note of that in my errata for this board. All right, so now we have a good clock. While we're doing some surface mount stuff, I would like to put on the LEDs for the FTDI, and then we could possibly be able to see if the FTDI is working or not. Turn that off, don't need that for now. So it was these chips. Let me reposition the camera a bit here. There. So I've got 2 diodes and two accompanying resistors. I had previously used, or had on the silk screen it saying 220s, but I was thinking, like when I was building the rest of the board, this diode up here, or this resistor for this LED, I put a 1K instead of a 220. And now that I can actually see with microscope, I can see that 2 of them are upside down, which, oh, a couple of them are upside down. All of them are upside down? I had such a hard time seeing that. Well. Let's put those 2 resistors on there. So that's... Come on, get off. Need to clean my tweezers a bit. All right. Let's move the... I guess I don't have any flux. The other spot where that other resistor was so covered, I didn't need to put any extra on. But in this case, we need more. All right, now it's the LEDs, and these are also 805s, 0805s, but they seem a little more intimidating than resistors and capacitors because you kind of don't want to. Oh, wait a minute. These are the sideways ones. I thought I was going to use the other ones. Darn. I have to find the other ones. Hold on. Now, which ones are which? These are the ones that I wanted. I also have some ones that I believe are the same, I mean, it says amber versus orange, but I thought they were actually like the same wavelength of light. That's in the plastic bag. These ones which have little lenses on them. And my thinking was, don't use the ones with the lenses because you need to see them sideways. I will explain more in a second. So I haven't actually seen what color those are. I haven't actually tried to run them. I did try and run these other ones and they were almost ready orange. But I also need to know the polarity of these. There's a little arrow in the back. And it would seem reasonable to assume that the arrow is the direction of conventional current. But what power is this using? Oh right, it's got a 3.3 volt regulator inside of the FTDI chip. So it looks like it's connected to power going through this way. So power is coming out of the resistors, going into the LED, through the LED and back. So we want the arrow to be in that direction, right? So arrow is pointing that way, we want it to be that way. Like that. Not enough flux. How about we gob solder on instead? Not surprising, that doesn't work. Never works. I always wish it would work so I could just tack it in place, but it never works. There we go. On other boards I've done, I've used not not this type of LED, but the what is it? The PLCC2 package. And they tend to have a plastic shroud or housing around them, and I always melt them. These ones oh, ha! That, I probably just fucked up the lens. I just like jabbed it. Maybe the lens did actually melt. Here I was being like all overly confident and stuff, and maybe it didn't work. Maybe you still can mess these up. But those other ones, the PLCC ones they're bigger, so they're easier to place. But the plastic melts if you put any amount of solder time on it. So how about I try not to melt the lens this time? Okay, that's that. I'm only populating one of the FTDIs for now because they are, I believe these were like $4 a chip or something, which again, if I'm gonna respin the board, then I might as well not populate it unless I need it, which the second UART would be, I mean, it's not even required because this one, the first one, is used for TTY for the console. For the next steps, I am going to I'm going to do the two PLCC sockets, and then I'll do the button and one of the LEDs, and then we can do some testing. Because at that point we're going to have enough that we should be able to get the CPU running if it's actually going to run, if there's not some other problem. CPLD, I believe, is programmed for what it needs, but we can also test that out later once we get the sockets in. It should just be, I would just need to reprogram it, so I think it should be okay. While I've got the iron on, we'll go straight into the sockets. And we will do the flash socket first. As you can see from the side profile, that is, apart from those pin headers, it's the next tallest component. The tallest components will probably be the LEDs that have a right angle adapter. You can just see that the bottom post there. Where's my tweezers? You can see in there the plastic nub that goes down is not touching the board, so it's lifting, the whole thing is up a bit. Oh, it's wobbling a bit too. There we go. It looks flush. There's no wobbling. Let's give it another quick go. Why does that one not look like it's soldered? It looks like them all. All right, next socket. This is saying up is that direction. Cut corner is that one. Should align like that, apart from the fact that one of the pins is bent because I knocked it earlier. Be sure to stick your fingers in the tacky flux so it gets all over your fingers. Loads of flux on the board, not on the thermocouple. Come on. If I didn't say it already, it's been a long day. That looks flush. I am gently blowing on it because I don't have my extraction fan out. My extraction fan is very noisy, unfortunately. So I haven't tried filming with it because it's just like really noisy. I probably should, because flux fumes are probably not good. Tends to eat my fingers too, my skin. I end up having all sorts of chaps on the tip of my finger. I think that's all. Just cleaning up a bit. All right, so all the sockets are in. We're not populating these because we've got the FTDI populated. These headers would just be if I wanted to hook an external one on there. I was going to not put the push buttons and LEDs in until I see something else going on with the board. But I probably should put the reset button in. And I might as well just put the status LEDs in. And then also I'm not going to put the bus connector on. I'll test it first. I have everything that I need for getting it up and running. It should be able to communicate on the FTDI. It should be able to run a program in the ROM and use the RAM to do something more than just a very simple program. Sorry for the noise. I'm just trying to clean my fingertips of that sticky, tacky flux. So these are the LEDs. They're open it under the table while whispering in your ear. How's it going? So it comes in two LEDs. These ones are green. I have yellows and I have blues. I was going to use yellows for this board. Now I'm kind of thinking like, why don't I just put them all on? But instead of doing that, why don't I check to see how much I paid for them? So the 2-button switch is actually only $1, but I only have 3 of them left. The reset button was $2.60, which is, for a reset button, that's a lot. This was only 38 cents, which that's cheap. But the yellow ones were $1.64, and I only got 4 of them because they were so expensive. So, in the interest of not using up the ones that I have, I won't put them on. I'll just put these ones on. This is for power and status. What do you think? Does that look aligned? Yeah, it looks pretty good, actually. I will go with it. Sorry about that, that was off camera. And we've run out of lights. I could do with a better lighting setup here. I'll clean my fingers yet again. Actually, let me just wash my hands quickly. All right. So, I could put the reset button in, but part of me is thinking I could just jumper it for now if I need to reset, because I kind of want to test things. And I'm also not going to wash the board off right now because I don't want to have to dry it as well. So let's start doing some testing. Get my oscilloscope probe out here. Let's start with some basic power. Let's double check that clock. We should, one of these LEDs is a power LED, so we should see some light coming from one of them. The other one is a status LED, which is driven directly by the CPLD. And I don't remember if it's doing anything yet. It might not be programmed to do anything. Don't have it hooked up. All right. Let's see if we can get the scope. I'd like to get the scope, the power supply, and at least part of the board if I could. Aside for now. It's a little messy at the moment, but we'll just have to make do. Power. Oh, wow, that is very faint. You can see that the power is on. Suppose I should have put the power on the other side, shouldn't I have? Wait, no, that's not power. It's the run light. So that's the status. That's probably the status. Let's just double check that. That might actually be the run light. If we take ground and, well, halt is going to be the other side of the upper LED, or the upper resistor for the LED. That makes it go out. Because it's actually just a voltage divider right now. It's really hard to see that, isn't it? It's just a voltage divider, and the CPU would pull it down when the when the chip is in halt. So it would be off when the chip is halted, otherwise it's running. So that's working. Turn power off. Can we check much with the FTDI? I suppose we can give it a try, see what happens. We could check the clock as well. Clock is 6.25. What's our minimum clock on this? Maybe that's a little low. I had intended for it to be a divide by 4, 50 divided by 4. But I don't even know what the minimum clock speed is. Oh, actually, no, I do know. It is 12.5 megahertz. So let's go to the computer briefly. There's our clock. So we're just counting the clocks and we're taking bit 2. So if we take bit 1 instead, we will be dividing by 4 instead of 8. Make that and then we will look up the programmer. Alright, powered down for now. JTAG on the board. We have to start the virtual machine. I would love it if there was a way to program this chip without having to use a virtual machine. Use Windows. All right, should be ready to go. While I'm doing this, I can quickly check with my fingers what the whether the transceivers are getting warm after we reworked the the pull-ups. But then I put a piece of lint on the board, trying to get this tacky flux off. My God. Bane of my existence, this tacky flux. I might be exaggerating. Okay, so while the board is programming itself, the outputs from the CPLD will not be pulling the output enables high. Instead, it would let them float, which makes them usually fall to 0, which makes all of the transceivers start outputting. And we put pull-ups on 3 of the transceivers, where only one of these 3 can be outputting at once, or one of these 2 can be outputting at once, because they output into the same bus, to the same signals. And the other day I had fingers on them while they were programming, and they burnt because they were using too much current. So, power the board, put some fingers on the board, and run. So far, so good. Yeah, well, that worked great. Excellent. At least I'm not frying those. They may be busted or something, but at least I'm not frying them. So let's check our clock again. What are we at? 12.5 megahertz, bang on. So that's the minimum clock speed for the 68030. So we should be safe on that front. I mean, I could check other things, but kind of just want to power through things. I'll take the JTAG off. So this is one of the CPUs that I have. And I have no idea if it is if it's a valid CPU, if it's remarked. Looks like it has some pins that were broken off and they've been resoldered on. Can I show that in here? You can see one of them there. So, let's see here. That one. That one right there, which has the sort of the collar. It almost looks like a pin from a like a low profile socket, a dip socket or something like that. Although, to be honest, the 4 pins that look like those weird ones are all in the same spot. It's this pin, this pin in the corner, this pin in the corner, this pin in the corner, and this pin in the corner. So given that they are such a regular pattern, maybe that's even like intentional from the factory. Clearly this is like a PCB chip carrier with the chip under this plastic here. I have not tested this. Like I say, this is the first board that I've made that has the PGA. The other board that I made is that. Very similar. I have the CPU down here. I have a compact flash card, which I don't have on this board. The expectation was to have a VMEbus card, a separate card that this CPU card could talk to access a compact flash card. Rather than putting it on the board, and I don't have a lot of space given the additional transceivers and the CPLD. The CPLD is replacing all of these logic chips. So it's just the clock that is being preserved here, and on this board I used the serial oscillator instead of the parallel oscillator. So I have 2 resistors here instead of 1 resistor here, but this uses well, I guess the other one used two gates as well, but this one has the 18 picofarad capacitors, whereas this one didn't need the capacitors, which was partly why I used it. That said, now that I look at this a little closer, I see some corrosion here. Getting distracted. Looks like those resistors are kind of corroded. Anyways, so yeah, this is a very similar board no transceivers, and static logic instead of the CPLD. I had some dip switches here. On this board, I just had jumpers instead. These jumpers down here are the two of the ones that were on here. The other stuff I can program with the CPLD, changing the CPLD program. And then I had straight up LEDs and buttons and stuff, whereas this one is going to be in a card slot. But since I know that this is a dual serial port controller, I know that this is valid and that this has a working program that should run on this board. Now I say that, but that's probably not the case, but it will do something instead of doing nothing, which is better than it, it's better that it does the wrong thing than not do anything at all. And if it does do the wrong thing, it's probably going to do the wrong thing because the I/O is like possibly in different addresses. That's going to be better than trying to dig out other things. And I should like find a better way to take these chips out than doing this, because this is probably going to break something someday. Now that I got that out, I think I actually do have a PLCC puller. But the last time I used it, I fumbled and it squished the chip in a way that could have caused even more damage than doing this. So I'll just do this. There we go. And it's out. All right, I'm gonna power it without the CPU, but with those chips in. What would we expect to see? We wouldn't expect to see the LEDs. If we actually had LEDs, we wouldn't expect them to see them come on. And the reset circuit should work fine, but we would jumper it if the CPU was in. I was gonna see if I could get the FTDI to respond first before I try these other things. But I don't know that it would. I mean, it should still... Oh, hey, we could test it. I have an FTDI here. Ah, crap, that's the other one. I don't have that end, do I? There we go. Found a cable. It's not long enough to put on screen though, so... TTY USB 0. So that did indeed show up without it being connected to anything on the other end. So we would kind of expect the same thing. Oh, hi. Nino Panda, thank you for the follow. So I'm gonna try and see if I can get anything to show up. Connecting the, this is connecting to my computer, and we're not seeing anything show up, which is disappointing. I feel like this should work. And if it's not working, then there's something wrong with the FTDI on here. We're not seeing any LEDs as well. We are not powering the board. Does that change anything? $700. That doesn't seem right. $700 milliamps. That is a lot of milliamps. I would have expected it to be less. I was not paying attention when after I plugged the chips in. We have two chips in here. This one was actually easier to get out, so I'll take that one out first. This is actually a, I guess, vintage chip. What's the date code? 92? The other chip is just a flash chip, and technically it is vintage as well, I think, but 1993 date code, but it could also be a rebadged. Not sure. Okay, so now we're getting 160. So this being in there was causing a lot of power draw. I would, oh, right. No, that should be okay. I'm thinking like the program in here, the CPLD program, I had it using the output pins from this socket and the input pins from this socket to control which of the transceivers would be enabled in order to try and debug that issue. I should probably remove that code or that logic. So if we go to the program here, move the video so that you can see. So I've just commented out the VMEbus stuff because that is, I'm not gonna try and get that working yet. And then I have these inputs things. They're all inputs, so it shouldn't be a problem. But I will just remove them for now. These are the GPIOs and for this dual serial port chip. It has, what is it, 6 outputs and 8 inputs or something like that, or 6 and 6. And I was reusing the pins to be able to control the CPLD for debugging, but I don't need those anymore. So that's these ones. Comment those out. So this will just make all the transceivers inactive. They shouldn't be controlling anything. They shouldn't be trying to do anything. While we're at it, we could probably take a look at some other things here. Just to see if there's anything unusual. RAM access, address decode, we should be alright. I don't see anything that should that should be causing a problem here. I need my programmer connected. So JTAG up. We are still powered. We have to reselect the file to reload it, and then run, and we get a failure. This is not very reassuring. Programmer is connected. JTAG is hooked up the right way. We have power on the board. We've got this chip in here. But that shouldn't make a difference. It shouldn't be connected to any of the CPLD lines except for the select line. I am a little worried that I just fried the CPLD because it's just not responding. Oh, there we go. Maybe restarting the programmer was enough because I had disconnected the JTAG programmer and then reattached it. That or who knows what else. All right, so that's now been reprogrammed. Now we're drawing 240 milliamps. That seems a little excessive, given that we don't have very many chips in here. Check these just to see if they are hot. CPLD is maybe a little warm. Let's go back to the schematic. Just take a quick look at the memory. So we've got read and write and ROM select for that chip, as well as the data lines and the address lines. I suppose adding the address and data lines could have taken a little bit more current. So that's maybe not unusual. But when we had this chip in here, it was taking like 700 milliamps, and that strongly implies a problem. This chip should only be taking like at maximum like 100 milliamps. So if we go from 200 milliamps up to 700 or 800 milliamps, this is taking 500 to 600 milliamps. I can't see that. That has got to be a problem. Either a short on the socket, which is somewhat unlikely, or it's a short because the CPLD program is incorrect. Or a short with the FTDI chip if I have it the IO is backwards or something like that. I suppose that is a possibility. Just out of curiosity, could I test those diodes, these diodes here? So we would need some ground, and it's in the middle of the chip. Well, we should be able to use any old ground. That is out of the socket. It's should use a resistor so I don't blow something up. That's not a good one. Let's find... There we go, there's a 1K. So that's a 10K. Do I have, oh, I don't have the microscope up. And you probably can't see that. It's 10K though. So I want to short the... Well, actually, before we do that even, we can just test the voltage. So the FTDI should be producing 3.3 volts out of its internal voltage regulator, which should be showing up on the other side of these resistors. And so we see that here on the oscilloscope. That's whoops. That's 3.3 volts. So we are getting power out of this chip. So it is sort of working, like power is working. We should be able to then short to ground. So if we short to there, I don't know that you could see that. I think I would have to switch to the go to the microscope view here. So that's ground. We see that that's working, and we see that that's working. So those LEDs are definitely working. We're not seeing any activity. They are very dim. I was a little concerned because the other board that I made that had LEDs, I had some blue LEDs on the board, and they're really bright. So I used the 1K resistors instead of the 220s, but those ones are really dim. Maybe I should have used the 220s instead, but it's good enough for debugging. Where's my cable? Still don't have anything showing up. Still don't see any activity out of that. That's a little concerning. Yeah, we're losing our light here as well. It's 9:30. It's been a long day. So when this serial port controller chip was in, we were getting high current. There was an issue with this as well, the CPLD, but what if we just loosely hold this in? Now we're getting 380. Okay, so that makes more sense. I'll stick that in a bit more. 380. Okay. I'm gonna call that good enough. Then this one. Now it could be like 500 milliamps if we power this on, but if it's anything more than that, then we probably got a problem. 430. Okay, that's reassuring. And would I push that in a bit more? It could also be that the chip is counterfeit and this is not going to work at all. 450, that's acceptable. All right, let's see some addresses. So the transceivers are probably going to be off, and we can't just poke at that stuff. We could possibly poke in the side, but we could also poke along, the RAM chips. They're probably going to be easier to access. So I want to see some low number addresses. The side here, these ones along the side are address 2 to address 6. So we would expect to see some happenings there. I think I'm gonna need to get the microscope out here. All right, so it's 65432. 6543. Two. Okay, that should be address line 2. We should see some activity, and we don't see anything. Address line 6. Okay then. Part of me doesn't want to throw in a chip that is more likely to not be counterfeit, because if it breaks, then that's like $40 or $50 I spent on a chip. On a used chip, an untested used chip. Great. I could try some reset stuff. I don't think that's going to make a difference. The reset circuit on this has got a power on reset, It's just not in focus, is it? I'll move this over here. There's where the reset switch would be. I could try jumpering that, but that's just going to reset things for the duration until I pull off. If I can even get on there. Go. $300. You see, we're really low on those. That seems too low. That seems like something is maybe going wrong. The CPU is not in halt though, because we can see that the run LED is on. So it's not in reset. But we're just not seeing any activity. What's our clock look like? Our clock is good. Where's our clock coming out of the CPLD? So it's right next to the ground pin here. So there, we've got 12.5 megahertz, so we're good on that clock. This is the CPU clock. Other things that we could test. Something to do with these. The jumpers. What did I have for the jumpers? So was that on the CPU? I had this jumper which pulls it to ground. Okay, so with that jumper not installed, it should not be suspending the CPU. CPU should be running. We've still got the run light. We've got clock. Can we look at the address strobe? The address strobe, the data strobe. Conveniently, the address strobe is the pin 1 of the CPLD. As I continually stick my fingers into the tacky flux. All right. That's address strobe. I mean, that could be low. Just feeling the board for any overheating chips. That could be what the CPU is calling low. Which, like if it was in the middle of a cycle, we would expect that if we reset the board, that it would change. That address strobe would go high at the start. Or low. That just doesn't seem right. I haven't really tested the CPLD program well enough. So I'm kind of suspicious of the program, the logic. But at the same time, I do not trust the CPU. So which would it be? Well, you know what? Just for the sake of it, it'll be easy enough, I think. I do believe. If I don't put the anchors in, if I don't solder the anchors for the reset switch, but I just solder the switch contacts themselves, that should be enough. That should be enough to reset. And then I don't need to do this later. And I can take this out. Easy enough, I think. And then at least I can just reset while I'm doing things. Okay. There we go. That way. There's our reset button. And with that, I can power the board up again. And we want to single shot with like 10 milliseconds at startup. That's probably, let's do 20. Rising edge will trigger. We don't have the scope on anything. We want it on AS. Well, that looks like what it should look like. And if we go back to auto, we see that. So that has got to be low. All right, let's single shot again. Let's do... This is probably not going to work because it never works. kind of worked. We are seeing activity, so I think this is a sign that the CPU is doing something. The address, so this is the address strobe. Power on is happening here. It's got some messiness there. I mean, if we zoom in, it's not even that messy. It goes up to a low level, which is probably during reset. So it's the CPU is commanding it to be a 0 while it's reset, and then it's going high, so it's inactive. And then it's going low again here, which that's not really all that low, but okay, whatever. Could we have contention there? Let me go back to here, make sure that the CPLD logic is using that as an input. Yeah, okay. So what I'm thinking here is that it's a problem with the acknowledge signal, which is often a problem that I have run into. And in this case, the CPLD, the program, the logic is not working, is not tested, so it could be not working. And that could be explaining why we don't seem to be getting any activity out of the CPU. This is probably the start of the first address fetch, which would be like the reset vector or something that it'd be fetching. But it's not responding. Or there's something more fundamentally wrong with the logic. Could well be. So let's look at DSACK. That's 8 and 9. I should have pull-ups for that. Yeah, DSACK 0 and 1, because it's a 2-bit acknowledge. There's 2 acknowledge signals. They are the size of the bus width, the bus port width. So if it's doing like, if it was an 8-bit port, it would always only do DSACK 0. If it was 16, it would do DSACK 1. If it's a 32-bit port, it would do DSACK 0 and 1. Would go low. This is regardless of the size of the operation. It's the size of the port. So you can interface to 8-bit devices, 16-bit devices, or 32-bit devices with the same CPU. You don't have to have a 32-bit interface for everything. This was like the era where they were making it easy and cheap to design boards, reusing the CPU for lots of things. where it could connect to everything, and then as speed became more of a concern, the CPU and the memory became more tightly coupled, and now you basically have to have the exact kind of memory that the CPU was designed for, because the RAM controller is built into the CPU. In this case, it's not built into the CPU. So we're looking at DSACK 0 is going to be that one, and DSACK 1 is going to be that one. So let me get back into auto. Oh, I have too big of a window, 5 milliseconds. There we go. That's better. Oh, right, power. Was wondering why we were getting nothing. There we go. Got some power, and our DSACK is low and low. Well, that we would expect them to be. We would expect one to be low. We would not expect both to be low. Well, actually, we would. Would we? We would expect it to be reading from the flash chip and not from the RAM chips. And the CPLD is going to be controlling the DSACK lines such that if it's accessing the RAM addresses, it will acknowledge as a 32-bit port, because the RAM is hooked up as a 32-bit port and the flash is hooked up as an 8-bit port. So it should be, if it was reading from RAM, it would have both of those DSACks low. If it was reading from ROM, it would only have DSACK 0 be low. So our address could be weird. Now, we're doing something a little funny with addresses. We have a chip up here. That's this guy, which is just an AND gate for the upper address pins. And that is outputting a 1. Now that should be 1 if all of the address pins are high. And it should be these are probably all low. I mean, I am seeing a slight difference, as if they are driven, and they're probably driven low because they're all zeros. And we would expect that because it's probably accessing address 0, which is the boot address. That's where it starts from. So the RAM is high because I believe that's an AND gate. Yeah, that's an AND gate. we should be able to actually see the RAM cell and ROM cell. What pin is that? 22. I don't actually know what pin that's going to be. Let me see better on the CPLD. RAM cell and ROM cell right beside the clock. Oof. So that's these two. That's not good if those are low. So it should be pin 6 of the RAM. It's already 10. I think I'm gonna call it a night pretty soon. I was only expecting to be on for a short time. We seem to have a lot of problems here, and a fair number of them seem like they could be CPLD related issues. It could be the CPU. We've got reset on here. We've got power. We don't have the other LEDs and the switches, but that's not gonna help us much if we can't run any code. Nothing is executing right now. I'm positive of that. And looking at those RAM select lines, they are they're all low, and only one of them should be low. So something is wrong, and I'll need to debug this a little further. But we fixed the clock. We fixed the transceivers. And we've got all the sockets in. We've got enough that we should be able to run code, but we're not, and the FTDI is not working. So something wrong with the FTDI, something wrong with probably the CPLD program. And I'll just need to spend some more time digging through the program, doing some testing. I'll wash the board off because I keep getting my fingers stuck in the tachyflux. And I'll lift the CPU out of the socket, and then we should be able to see, like, well, with or without it in the socket, we should be able to see one way or another. I'm just like thinking in my head, oh wait, the address strobe won't be pulled high if the CPU is not in the socket. So we can always like fudge that if we need to. Stick a jumper in there to make the address line high so that we can then test the CPLD to make sure it's responding the way it should be. Clearly it's not. Clearly there's something wrong. We are seeing something on the address strobe. And the CPLD is only using the address strobe as an input, so it has to be the CPU that is controlling that. If the CPU is the only thing that could be controlling it. So the CPU is doing something, and it seems to be trying to fetch an address, but it's just not going through. And on the previous board, I had issues with pull-ups. And now that I actually look at the board, I did actually put smaller pull-ups on there. And very conveniently on this board, I say that sarcastically, I use these resistor networks. And these are our 10K resistor networks. And I've got 4 signals on the ones that have the DSACK lines. The other ones are B-air and something else. What the hell is that? So that's the one with the DSACKs. S-term. S-term and B-air. So I think I used 22 kilo ohms, or 2.2 kilo ohms, I should say. They're red. So I used 2.2K pull-ups for the DSACK lines on the other board. So I could buy another 2.2 kilo ohm resistor network there and replace the one on this board with a different one, and it would be okay if the B-air and that were also exchanged. I guess I could quickly check that before we go. So we would expect to see something on one of these. Honestly, I'm not seeing anything. I'm not seeing any change. That's generally not very good. So let's see, single shot, we'll put 20 milliseconds, power on, Okay, so that is kind of doing something, and we would kind of expect it to do something because the CPLD is probably trying to pull DSACK low. So it does initially during reset, I assume while the dress strobe is, like, that's probably the power on right there. So a dress strobe is probably low through here. And then, wait, is it low? Well, it's in reset. I don't know. It is possible that we have a problem with not pulling things back up quick enough. So I should buy that. I should put that on my list. Get some smaller. I could get some like 1K and 2.2K resistor networks. And let's power the board off. Despite that, there may still be other issues. I'm not even sure that the FTDIs are not working, so I still have that like sneaking suspicion in the back of my brain that maybe the FTDI's send and receive pins are backwards, but even with this pin out, with this chip out, we were still getting issues. So maybe not. I am just going to quickly hook up this other board. Oh, we don't have chips in it. That should be okay. Let me just verify the power. Yeah, that's correct. I just want to take a look and see if I can see the same. I have to pull this up. If I take a look at this board, DSACK 1, 0 and 1, 5 and 6 of this guy. One, two, three, 4, 5. That should be DSACK 0. Really? That's what it looks like. I was not expecting it to be even worse. But also this board is only taking like 100 milliamps. I mean, it's not responding. These chips are out, so it's the transceivers on the other board that take like 200 milliamps. Well, we are getting that little blip at the start, so there's that, but those seem even slower. So I would expect that's opposite what I would have expected. I would have expected a sharper rise, but yeah, I guess that's for tomorrow. I may be around tomorrow. I might do some debugging off camera. Might do some debugging in stream. Might start to stream, but tomorrow is cleaning day, so even though I mostly cleaned everything, if I'm not back on Saturday, then I will probably be back on Sunday, and hopefully I can get the board executing code. What happens if I do get it executing code? I guess we'll see how stable it is. If it is decently stable, I guess I could put the VME connector on. I could like do some debugging of the CPLD, see if I can get the CPLD to a state where it can control the VME bus and the transceivers. And then it will be it'll be possible to access the other cards that I have. I have 2 other cards that I would like to build during the break, but they kind of need this board working in order to be able to access them. I do have another board that I could possibly try programming to act like a controller, but ideally I would be getting this board working. And it's possible. So far, it's these output enables that I had to rework in, but they do seem to be working. They are the board. I can program the CPLD without them burning up. They may be broken still, but they also shouldn't be. As I say that, part of me wonders, like, what if they are actually broken and they're interfering with the CPU bus somehow, like on the CPU side, on this side of the board. It is possible, but yeah, I would say it's unlikely, given that they were seemingly working without shorting when I was testing them earlier, so yeah. I guess before I go, since I've got this all set up, what if I try giving that FTDI a little bit of heat? I don't even have my thermocouple there. This is just to save me having to dig out the hot air rework stuff again. I mean, I might have to again anyways, but like... try reflowing that chip and see if it does anything. Not expecting any change here. Power on. And nothing. Kind of a little unusual that it's only 200. I did not fully seat the chip. How likely do you think that was actually the problem that we were having? I mean, I guess it's possible, but I kind of suspect that it is not our cause. I'm sure we've got issues with the CPLD. I mean, we do see it do something. Well, that didn't change anything. It's maybe still not fully seated, but I also don't want to have to take it out. I want some space so that I can pry underneath with the chip puller that I have, so yeah, I'll call it there for tonight. That was a lot longer than I was expecting to be, another 3 hours. I'm sure it was very boring, but hopefully it wasn't like, you know, hopefully for the brief periods you were here, it was somewhat entertaining, if only in an ASMR sense. Yeah, thanks for joining. If you did, I will probably be back either tomorrow or Sunday, and we'll go from there. Bye.